What is up, guys? Fahir here from AwesomeTuts.com, and moving forward with our robot game. In the previous video, we coded the flying and we also coded the shooting of our robot. Now we want to code the rocket launching part. So when we press the C button, we want to launch a rocket. But before that, this video has been sponsored to you by AwesomeTuts.com and their new 3D game development course. If you want to learn 3D game development, this is the best course. One-stop shop here for you for 3D game development, for 2D game development, also in Unity game engine. No better course out there, I guarantee it. All of the students in the course are satisfied. They are learning a lot of things. I get messages all the time. People thank me for the course. They are learning a lot of good things, especially C# and good programming principles and writing clean code and not going all over the place and writing, well, shitty code, so to say. Anyways, if you're interested in that, go and grab it on my website. You don't have nothing to lose but a lot to gain. 30-day money-back guarantee if you're not satisfied, but you will be satisfied for sure. This is my guarantee. And if you are interested in downloading this project and the assets for this project, link is in the description below. Go on the link, enter your email, and download the project. That way you will get on my mailing list and you will receive course discounts. So now moving with the tutorial. Here we are going to test if input dot get key down, and it's going to be key code C, and I will tell you why is it key code down in a moment. And here we are simply going to call launch missile function, which we did not create still. So I'm going to go here and type void launch missile like this so that we don't get this nasty error here. And why get key down? Well, first of all, I'm going to show you when we type get key. And here in the function, I'm simply going to say print, and I'm going to say key pressed like this. If I go back in Unity, and I'm going to clear the console, and I'm simply gonna, let me just go here, clear everything. This is from my previous testing. Don't worry, everything works. So when I hit the play button, and when I press the C key, so I'm pressing and holding the C key. Notice, it is being printed in the console so far 267 times. I have released the button right now. So when you use get key, when you use this here, let me just find it. Get key will get you when you press the key and as long as you are holding that key. So if you only want to detect when the key is pressed, you're going to type get key down. If you want to detect when the key is released, you're going to say get key up. So when you press the key, this right here will not be executed. Only when you release, so when you put your finger, release it from that key, this right here will be called when you use get key up. When you use get key down, only when you press the key, it will be detected. So notice in the previous example, we had 267 times printed in the console key is pressed. But notice now I'm going to press the C key. So I have pressed it and I'm holding it down. My button is, or my finger is still on the button. And only once it is printed in the console key pressed. I have just released my finger from the button and everything is okay. The reason for it is, well, here when we use get key down, we will detect when we press the button. This is what we want because we don't want to launch missiles as long as we are holding the button. That will be like 300 missiles in a second. And if you're building a game for mobile device, that is not a good idea. So inside of our launch missile function, we are simply going to detect if our lean tween is tweening. So if the lean tween is not tweening the game object is not being tweened, what we want to do? Well, first we want to get the position. So we're going to say vector3 POS, short for position, is equal to the current position of the robot. So transform that position because the robot holds this script. So we are going to get the current position of that robot. Next, we are going to test where is the direction of the robot. So if direction is equal to the direction right, we're going to say POS, so the position dot X is going to be plus equal to 1 because we will see that in a second. And we are also here going to say POS dot Y is going to be plus equal to 1. I'm also going to copy this line of code and test if the direction is left. And in this case, the POS X is going to be minus equals to 1. What is this, in fact? Well, it is that we are going to spawn the missile by using the, well, POS, this right here. So if our robot is facing the direction right, which will be this right here. So if he is facing the right direction, so here, where he is currently facing, we're not going to spawn the rocket here where my mouse is pointing. Instead, let me just go here, highlight. So we're not going to spawn the rocket from here. Instead, we are going to move it a little bit here and spawn the rocket from here. So from here is going to rocket, or the rocket is going to go. Same thing if he is facing left side. So we will not spawn the rocket exactly where the robot is. Instead, just a little bit in front of him. So just a little bit in front of him, we are going to spawn the rockets. And this is what we are doing with the direction and testing, well, the direction if it's left or right. So now we are going to spawn 5 rockets at once. So we're going to say for int I, which is equal to 0, as long as I is less than 5, increment I by 1 and do the following. And what is the following? Well, the following is vector 3 origin, which is equal to POS plus vector 3 up. Multiply that by a random dot range from -1f to 1f. And also we're going to say plus vector 3 dot left. And we're going to multiply that by the random range from -1f to 1f. So what is this doing? Well, essentially we're simply adding to the position vector 3 up, which is, well, 1 up on the y-axis. So vector 3 up is 0, 1, so 0, 1, 0. And we are multiplying that with the random range from -1 to +1. This is just gonna randomize the rockets. So for example, if I go here, again the highlight tool, so when we spawn the rockets, we don't want to spawn all of them from this single point. Maybe we want to spawn one from here, one from here, one from here, one from here. So this is what this line of code is doing. This line of code here will make us or enable us to spawn those rockets from this point, that point, not from one single place. And we will see this in a second. Next, we're going to see here GameObject.temporary is equal to instantiate the missile, and from the origin position, and, well, for the rotation, we're going to say quaternion.identity, or actually quaternion.angle axis. And for the angle axis, let me just go here. And for the angle axis, we're simply going to say if the direction is equal to direction right, question mark 0f, otherwise, so colon 180f. And here I'm going to say comma, and the axis is going to be vector 3 up. And we're going to say this as GameObject. So what just happened here? What are we doing? Well, if I go here and type quaternion.angle axis, notice the summary, creates a rotation which rotates angle degrees around axis. What does this mean? Well, it will rotate, this angle axis will rotate this GameObject by this many degrees on this axis. Vector 3 up is the axis, which is the y-axis. Vector 3 up is, we know, 0, 1, 0. So if I hover over this up, it will say summary, shorthand for writing vector 3, 0, 1, 0. So this is y-axis. This is the y-axis. And what is this here? I forgot how this statement is called, but this is a shorthand for writing this. If direction is equal to direction.right, then we will say here some value. So int some value is equal to 0. Actually, here I need to say it like this. Some value is equal to 0. Else, I have troubles writing this code, so excuse me for this one. Else, some value is gonna be equal to 180 degrees. So essentially here we are asking if the direction is equal to the direction right, question mark. So this is the if statement. If direction is equal to direction right, question mark. If this is true, so if the direction in fact is equal to the right direction, the value will be 0. Otherwise, the value will be 180. So this is equivalent to writing, or this right here is equivalent to writing this. Again, this means if direction is equal to the right direction, value will be this one. So if this is true, the first thing after the question mark will be executed, in this case 0. Otherwise, colon, otherwise, 180 degrees. As game object, meaning we are casting it. So we are telling it created as a game object. When you see this as, that's called casting. And that is, well, simply put, it is telling C#, it is telling Unity, create this as a game object. We want it as a game object. So now we are simply going to say here, vector3 target position is equal to missile point. So missile, did I type it? How did I create the, did I type missile point? Yeah, here it is, missile point. I don't know why it didn't give me autocomplete. So vector3 target position is equal to missile point dot position plus missile point dot forward multiplied by 20f plus missile point up multiplied random dot range from -1 to +1. And what is this here? Well, this right here is where our target is gonna go. So where is the missile gonna go towards to? So it is gonna go from the missile point position plus the missile point forward. And if I hover over forward, it says the blue axis of the transform in world space. Let's go and check that out. So if I select the robot, the blue axis, this is that one. This right here, this is the blue axis in world space. So wherever this blue axis is pointing at the moment, that is the forward of the game object, because it can point to the left, or which is right, or actually it can point to the right, which is at the moment, and it can point to the left if we rotate, or it can point backwards if we rotate like this. So depending on the rotation, this blue axis will point in a certain direction. So this is that missile forward. We're multiplying that by 20. And plus missile point up, as you can see here, it says up. Let me just hover over it. It says the green axis of the transform in world space. So it's this one right here. This one right here. Same concept as I explained. And we're multiplying that by the random range. Next, we need to take the temp. So here I'm going to say temp dot send message. And we are going to send the message called launch missile. And we're gonna say comma target position. What the hell is this here, teacher? What are you doing? Well, I talked about send message in Jumpy Cat, I think. Yeah, it was in Jumpy Cat. I talked about send message. This is gonna go into the game object, which is our temporary, which is this one right here. It is gonna go and send a message to that game object. That means it will go to every single script attached on that game object, and it is going to call a function called launch missile. So that's the name of the function that we want to call. And in every single script attached on that game object, which is the missile. So in order to move the missile, before we can test it out, the missile will not move currently because we need to create our script for that. But we can go here and we can test it out. So if I press C, and did I press C? Yes, I did. And voila! As you can see, I pressed C, but nothing is happening. The missiles are not moving. We have here a problem. It says send message has no receiver, meaning we did not attach a script on this missile game object. So I'm going to go here and click on new script, and I'm going to create an ad. What did I do? Audios. Let me just remove this script and go back here. Audio, so I'm gonna remove it and go like a gentleman. And here I'm gonna create a new folder and I'm gonna call missile scripts. Inside of that one, I'm gonna create a new C# script and I'm gonna call it missile script. And go here into the prefabs, select the missile and attach the missile script. Voila, like a gentleman. Double click it, open it in MonoDevelop, tag it with the class. This is of course me, you don't have to do that. And we need a couple of variables. The first one is gonna be public game object explosion. Now this explosion we need to import. So we need to go back here, right click, and go into import package and custom one. And it is gonna be this mesh explosion. Or is it actually explosion here? I think it is explosion. Yeah, this one. I'm gonna import explosion and I'm gonna click here, import, and voila, here it is, the explosion. Let me just put it here. Yeah, this is the explosion that I want, this one. So this is the explosion we need to drag. Let me select the missile, and here we have the component. So drag and drop the explosion here. So simply drag and drop it, and on the explosion we need to create one other script, which is, if I go back here, scripts, missile scripts, I'm gonna create it here. C#, not JavaScript. What is wrong with my computer? It's acting a little bit strange. So this one is gonna be called, let me see if it's not overheated. No, it's not. So this one is gonna be called explosion script. Go back into the prefabs, select the explosion, and simply attach the explosion script. This one is very short. Nothing to write except to destroy the game object. So here I'm simply gonna say destroy, like this, destroy game object after 1 second. And that is that. Because we don't want the explosion particle effect to be in our scene after it plays the effect. We only want the effect to play once, and voila. Then we want to destroy it, remove it from the scene because we don't need it. So destroy the game object after 1 second. In the missile script here, I'm also going to remove all of this here, and I am going to create a void launch missile, which is this one right here in the player script. This one, the name here, so the name here needs to match with the name here. And of course, this needs to take a vector3 position or target position. Why is that? Well, because I've talked about this. We talked about send message. It is going to go in every script attached on this game object and call the function with the given name. But we can also pass a parameter. This target position is the parameter which is going to be passed right here. So when we call this function by using send message, it is also going to carry this parameter which we have calculated here, and it is going to put this parameter right here. So this is what we are doing. And now we can simply invoke here. So we can say invoke. And here I'm simply going to say set active, comma, after 0.9 of a second. This set active is going to be declared here. So void set active. And here we're simply going to say get component, collider, and we're going to say here dot enabled is equal to true. What does this mean? Well, it means that on our muzzle, or actually on the missile, notice we have box collider who is not currently active. So he is not active. And we want him to be activated. So we will activate him after 0.9 of a second by calling this function. So set or invoke will call this function after this number of times. So it's 0.9 of a second, almost 1 second. It will call the function named setActive, which will activate the game object. The reason for it is because in void on trigger enter, which takes a collider, which I'm going to call target, we are going to detect the collision. And in order to detect the collision, well, the missile's box collider needs to be active. Now, going here into this launch missile, this is going to move. So this is the function that is going to move the missile. And for that, we're going to use the lean tween dot move, and we're going to move the game object. We are going to move it to the target position, so target POS, and we're going to move it in 1.6 seconds of time. And here I'm going to say set ease, which is the curve. So it's the curve of the movement. And it is going to be lean type, so lean tween type easy or ease in back. And if I hover over it, let me just wait, is it gonna show something? Actually not. So let me just type it like this, lean tween type dot ease back, ease in back. It's not gonna give us any explanation, but essentially it's gonna move it a little bit backwards, you know, like ease it back and then, well, shoot it to go in front. And here I'm gonna say set on complete, and on complete is gonna be explode. Explode like this, which is, well, the function that we did not create. So here I'm gonna say void explode. Inside of this void explode, we are simply going to say instantiate the prefab, which is explosion, at the transform.position using quaternion. Again, let me just go here. It's quaternion.identity. Now this quaternion identity is simply 0, 0, 0 for the X, Y, and Z axis. After we instantiate the explosion, we are going to destroy our own game object. And also here, inside of our void on trigger enter, we are going to test if target that game object that layer is equal to the layer mask dot name to layer, and it's gonna be ground. Now we are testing if we have collided with the game object that has a layer called ground, and we need to end the statement here. So let's make sure that we need to go here and select everything in the map. I'm actually gonna select the map and go here, add layer. It's gonna be the ground, and I'm gonna hit, well, like this. Create here the layer, and actually, should we create, yeah, the wall is on the ground, cube also, the boxes, yeah, everything is set on the ground layer, as we see here. Because we created the ground layer, and they are automatically set to that ground layer because in the project I worked on, they were set on the ground layer, and we have imported it, and it memorizes those things. So as soon as we created the ground layer, they are set on the ground layer. So going back here, if the game object we collide with is set on that ground layer, and this is how we check if he is on the layer mask, name to layer, ground. So if if some of these game objects are set on the ground layer, then what we want to do, well, simply we want to say if the target dot tag, so if the tag of that game object is equal to the box, then we are simply going to say target.get component, and it is going to be the rigid body component, dot add explosion force. It says applies a force to rigid body that simulates explosion effects. So we are going to simulate the explosion effect by using here 2000F, and the explosion position is going to be the transform.position, and the explosion radius is going to be 6. Else, if target.tag is equal to the enemy, then what we want to do is we are going to say target.send message. So send message, and here we're simply going to say damage. This is going to be in our enemy script. So at the moment we don't have it, so do not worry. And simply here afterwards, so here I am simply going to call explode so that, well, our game object explodes. So we can test it out, and then I will go back and quickly explain everything what it is. And let me just lower the volume a little bit. So notice now, when I hit the button to run the game, notice now. So did you saw that? Of course, we need to also take our explosion here, and it needs to have an audio source, and I need to attach on it the explode. So this explode needs to be attached so that we hear the explosion. So again, let me pump up the volume. So did you hear the explosion? And voila, this is the explosion effect. Again, how is it done? Well, of course, here in the launch missile, we're going to detect if we press the C on our keyboard, we're going to call the function. The function here is going to test if the tween is not tweening the game object. If that is true, get the current position of the game object and see the direction where the game object is facing. Because notice where these rockets are spawned. So notice now. Did you see where they are spawned? So not on the game object itself. They were not spawned here, but you see they're randomized. Again, let me just go here. They are randomized. One is up, other is down. A third one is closer. Another one is, well, not closer. It's far away. Well, this is what we are doing with these here. So we are going to position it a little bit in front of our game object or backwards depending on the direction. After that, we're going to spawn 5 rockets using this origin, which is, well, our current position, this one right here, and we are randomizing it here. So we are adding upwards the random range, or up and multiply that with the random range, and also left multiply that with the random range. Afterwards, we are going to instantiate that game object, which is our missile, at this position, which is this one right here. And using this angle axis, which is going to rotate the game object depending on the direction. If direction is right, it will rotate it to 0. If it's left, it will rotate it to 180 degrees on the y-axis. And then we are calculating the target position, which is, well, here. This is going to be that target position where we are going to move towards to. So the target position is where we are, in which direction, to which target, where we are moving. That's the target position. Then we are sending a message to every missile that has a launch missile function in any one of the scripts attached on it. Again, you can go on Unity documentation. I talked about this. I talked about this in the Jumpy Cat. So send message will go on the game object and search in every script attached on that game object for a function with this name, and it will pass this parameter, which is, voila, right here. So it will go into this function, pass this parameter, the target position, right here. It will pass it through this parameter, and now we can move that game object to that position in 1.6 seconds with this easy movement. This set ease is the movement. So it's going to be ease in back. That's the movement. And when it completes, so when the movement completes, call the explode so that we destroy the game object. Of course, here we are invoking set active to activate the collider so that we can detect collision here. So if we touch a game object on the ground layer, of course we can remove that. So we can simply remove all of this here. So we can remove this and simply put this here. It will also work. But I just want to show you how you can test if the game object is on a certain layer. So if that game object is on a layer called ground, if the tag of that game object is box, which is, so if I go here, since we imported, notice we imported these boxes and, well, their tag is box. So we imported their tag also along with them. So their tag is box. And if the tag is box, get their component, which is the rigid body, and apply explosion force, which, well, I explained. It will apply a force to a rigid body that simulates explosion effect. And this is how hard that explosion is, at which position will that force be applied, and this is the radius of it. If the target is tagged enemy, then send the message damage to kill the enemy. After that, explode, meaning destroy the game object and instantiate the explosion effect. Let us test it out one more time before I end the video. Bam, 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 and it works. So, Fire here from AwesomeTuts.com, and let me just go here. It says explosion is missing. So explosion, let me see what it is missing. Yeah, let me just remove this script from the explosion because we attached this explosion script, which is gonna destroy the game object after 1 second. Anyways, Fire here from AwesomeTuts.com. Go on my website, get the course. You will not regret it. So this will be the investment of your life. You will love it for sure. And if you don't, there is a 30-day money-back guarantee. If you want to get the assets and this project, link is in the description below. Go on the link, enter your email address. You will receive a link to download this project and go crazy with it. I will see you guys in the next video.